Hello, quick video on one pager for MEI C4, which is uses of pure maths. And this is a one-page mind map that I created to work with my students for their exam. And it covers the syllabus and the exam questions. So let's have a quick run round. Partial fractions, they're going to ask you to use these to prepare an expression for integration using the 3 rules in the square box. Binomial expansions, they're going to ask you to look at fractional and negative powers, indices, and what the ranges of validity are. So here particularly we've got to remember that they're going to give us something that looks like a plus x to the power n, and we've got to take the a out the front. And that means our validity range is for x over a, which is inside the bracket. They're going to ask us to do first term, so they're going to ask us to do an approximation for the first 3 values. And also they may give us something where there's a binomial expansion required on the denominator before multiplying by a numerator and taking the first 3 terms. Trig identities, you need to know your cos of 2 angles, your identities that go with it, and also your cos squareds into double angles. R cos x minus alpha for an expression a cos x plus b sin x. So effectively here we're going to find the magnitude and we're going to find the phase angle. So we're going to find r and alpha using the formula, which allows us then to find the maximum value and solve equations with it. The trig equations they may ask us to solve are either going to be linear or quadratic. You need to convert those into a single trig variable and then use the graph of those trig variables with horizontal lines for our roots that we're substituting in to find your points of intersection. There are solutions, and over them watch out that you're in the right range. Parametrics, now we're into section B. You've got parametrics, differential equations, and 3D vectors. So I'll spend a little time on these, a bit more time. Parametrics, they're either going to give you a t parameter for parabolas and reciprocal type things, or they're going to give you a trig one, a theta based one, which for circles, ellipses, and that sort of stuff. Both of them use the same differential approach of chain rule. Cartesians, with a t variable, you can substitute straight in by making the t the subject of one of the 2 equations you've got. In the trig situation, you need to use a trig identity and substitute x and y into that trig identity. You're going to be asked to find max and min, and they might actually ask you to find vertical extremes, the maximum x, maximum y, a maximum x rather than just a maximum y, and therefore you need to look at dx by dy equals 0 as well. Differential equations, they're going to take you through potentially from the creating a proportionate relationship and solving it. Remember, for solving, we're going to separate our variables, we're then going to integrate either side, then we're going to substitute, we're then going to integrate, and then we're going to use our initial conditions to set the constant between the 2 sides. They may well ask you to find the future points, like t equals a value, or when t tends to infinity. Now, quite a lot on 3D vectors, but there's actually less than you might think. So they may ask us to find distances between points using 3D Pythag. They will definitely ask you about some lines. They may create line equations, and they may ask you to, for 2 lines, look at whether they're intersect, parallel, or skew. So let's bear in mind, if they're parallel, if the L values are parallel and one's just a multiple of the other, intersect or skew, well, to intersect, then we must have a solution for a particular parameter lambda where the x, y, and z are all solved. If there isn't a single solution, then you're in a skew situation. Okay. Scalar product, what are they using that for? To find the angles between vectors a dot b, and also to find right angles. So if a dot b equals 0, because cos is 0, then they're at right angles. Which neatly brings us on to planes. Quite often they're going to give you points in a plane, and then you have to show that a particular vector is the normal to the plane. Remember that if we've got 3 points in a plane, we can create 2 vectors in the plane, A to B and A to C. And if they're perpendicular to the normal vector, the normal is at right angles to the plane, then the dot products are 0. We then have to find the constant to go into our plane equation. We can do that by substituting any point in. Last 2 bits. Finding the intersection of a plane and a line. Well, what are we doing here? Well, we're finding the lambda value. We're coming along the line till we hit the plane. So we substitute, therefore, our x, y, and z from the line into the plane equation. We find the lambda that works. That's the point of intersection. And a little variant on that is when they ask us to find the distance from a point to a plane. Well, the closest point will be, or the nearest distance will be, when the line we're going along is at right angles. So that's going straight down the normal vector till we hit the plane. So we've just turned that into a line problem, haven't we? We're starting at the point, we're going straight down the normal until we hit intersect and find our lambda. And once we've found that point of intersection, we can find the distance with 3D Pythag. So there you go. Best of luck.